Previously, we explored various deployment scenarios. We deployed applications and feature branches using both predefined and custom pipelines, integrated automated testing into our workflows, and managed multiple deployment stages. However, all of these deployments were performed within a single cluster. Today, we are taking the next step by exploring how to extend your deployment capabilities across multiple clusters. Business requirements often demand multi-cluster architectures for several key reasons: achieving high availability and disaster recovery, reducing latency by deploying closer to end users in different regions, and meeting compliance and data sovereignty regulations. It might also be helpful in maintaining isolation between production, staging, and development environments. Generally speaking, to integrate external cluster, we need the target cluster itself, of course. Then, we will need credentials to access this target cluster from the main workloads. It could be a bearer token or another specific credential form, such as IAM role for serviced account. And finally, we need to configure the platform to recognize and utilize these credentials, enabling deployment to a remote cluster. Okay, now that we have known what we need to integrate a cluster, let's integrate one. As we already mentioned, we can use various credentials for integrating clusters, such as IRSA or bearer token. In this practice, we will be integrating a cluster using IRSA. We will be doing guidelines outlined in 2 pages. The first one is deploy application in a remote cluster via IRSA. The page describes the architecture and principles of AWS cross-account relationship and which IAM roles they require for connection. Next, we will be following the Add Cluster page. This contains guidelines we need to perform in the KubeRocketCI portal. Please note that we expect you to already have AWS accounts, EKS clusters, and IAM roles created as a prerequisite. Refer to the AWS guidelines on how to set them up. Let's get started. To start from, let's add our remote cluster credentials. In the KubeRocketCI portal, navigate to Configuration, Deployment. In the Clusters tab, click Add Cluster. Select IRSA and fill in your cluster's data. The cluster name field is arbitrary, but remember this name as you will need it in the following steps. Click Save. Great. Now let's switch to the terminal to run kubectl commands for further configuring the platform for remote cluster integration. To bring clarity in what we are going to do in the nearest minute, let us briefly explain. Firstly, we will add annotations with an IAM role to the service accounts that belong to KubeRocketCI and Argo CD. We will also restart the deployments to apply the changes. This will grant these components sufficient rights to access resources in the remote cluster. Secondly, we will add a new destination with the remote cluster to the app project resource. This will let Argo CD know where to use the new IAM role. Now let's get back to the terminal. First, we need to patch the CD pipeline operator service account by adding an IAM role annotation. Run the kubectl patch command and insert your IAM role ARN and account ID. This will assign the IAM role to the service account. Next, we need to annotate the Argo CD components. Run the kubectl patch commands as we did for the CD pipeline operator. Keep in mind that all the commands are provided in the documentation. This time, we need to patch the Argo CD application controller, application set controller, and Argo CD server. After patching, restart the pods to apply the changes. Now, add the remote cluster endpoint to the app project resource in the Argo CD namespace. The app project should match the namespace name where your KubeRocketCI instance is deployed. OK, now let's update the config map called KubeRocketCI config, so the newly added cluster will appear in the available clusters list when creating an environment. Navigate back to the KubeRocketCI portal. Switch to Kubernetes mode. Select Configuration, Config Maps, and find the config map using the search filter. Enter the config map and click the Edit button. In the Data field, add the available clusters parameter with a value matching the exact cluster name you specified in the configuration section. To add several clusters, specify their name separated by commas. Once the variable is added, click Save and Apply. The last thing we need to configure is creating a secret that will contain the cluster data in the Argo CD namespace. Again, the secret template is provided in the documentation. To save time, we've already prepared a ready-to-use secret, so we will simply apply it. Now we are all set to create an environment that will deploy our applications to the remote cluster. To clarify, we've just created a new Kubernetes secret named cluster-name-cluster to allow KubeRocketCI to create a temporary credential that lets the platform log into the remote cluster. The new cluster should be added to the Argo CD clusters list. To check that, open the Argo CD endpoint, navigate to Settings, Clusters, and find your newly added cluster. Pay attention to the connection status, it should be successful. Navigate to Deployment Flows, enter one of your deployment flows, and click Create Environment. In the Create Environment window, the very first field is the cluster where you wish to deploy your application. Now you can select either the external cluster or your newly added remote cluster. Select the new one and fill in the rest of the fields as needed. Now, we are finally ready to deploy our application. Deploy our application as usual. In the Overview tab, you can see that the environment is configured to deploy apps in the remote cluster. You can also verify this by checking the kubeconfig secret name parameter in the Pipeline Run Details page. As you can see, the application is deployed successfully. In this video, we've demonstrated the complete process of integrating a remote EKS cluster into KubeRocketCI platform and deploying an application to it using RSA authentication. Briefly speaking, we create a cluster, generate credentials for it, apply them in the platform configuration, and then set this cluster in our environments. This multi-cluster capability enables us to build sophisticated deployment topologies that meet high availability, compliance, and geographic distribution requirements. That's it for today. Thank you for watching.